Right. Thanks, Sheena. Okay, so hi everyone. Thank you for joining this edition of our Tech Talk. So today will be the part two of our session that we have covered last month, but where we in which we're talk about how you can easily codify and automate your Exadata database service deployments using Terraform with the ready OCI Terraform landing zones for Exadata database service. So my name is Leo Alvarado, and with me is my co-host Sheena. Um, so we're both part of the product management team for database cloud services and multi-cloud. So hi Sheena, thank you for joining the Tech Talk.
Hi, Leo. Thank you.
Okay, so just to do a recap, so what we have covered on the part one of this Tech Talk about codifying and automating Exadata database service deployments is that in OCI, so we've covered that you have this powerful tools. Like we give you an option, like we give you a choice, like we give you these different management interfaces that you can use to manage your database cloud services, specific also to your Exadata database service. So you can use, of course, the OCI UI, and then if you prefer to do a more programmatic interface for things done repeatedly. So you also have the REST APIs, and then for building custom tooling or scripting, then there's also an available CLI, which we call OCI CLI. We also have SDKs that you can easily integrate with common languages such as Java, Python, Ruby, and Go. And the main focus for this tech talk, it's all about managing your infra as code using Terraform. And on our part one, we'll also cover that um, the concept of infrastructure as code. Like adopting infrastructure as code really transform the way you manage cloud environments. So you can define your entire infrastructure, servers, databases, networks in code, just like how you do it with your applications. And what we have covered last time is the core concept behind infrastructure as code. Like instead of like why infrastructure as code. So instead of provisioning infrastructure manually every time in the console, so you also have another option, which is to manage your infra as code, which lets you express that in that configuration in file. So meaning you can you can version it, you can review it and share it. So just like any normal application code. So if your team needs to deploy the same environment multiple times, for example, if you want to create multiple environments for development, test, UAT, and prod, then you can apply the exact same configuration with consistency. And we've also covered this in the part one. Like um, you can use infrastructure as code with Terraform's ready-made providers and resource definition to seamlessly automate and manage OCI deployments, including your Oracle database cloud services. So one of the great things about Terraform is that it comes with this ready-made providers and resource definition. So if you looked into OCI Terraform provider, and then under the database. So you'll see all these ready resources that you can use for deploying your Exadata database service on dedicated infrastructure. So there are ready resources that you can call in Terraform for creating your Exadata cloud infrastructure, creating and deploying your Exadata Cloud VM cluster, creating and deploying Oracle Database Home, deploying container database, which is the fourth bullet here, the database underscore database, and also deploying and managing your pluggable database for that specific container database. So if you want to start with Terraform, so you need to build your Terraform script with all this required resources. So for example, if you're deploying Exadata database service on dedicated infrastructure, so you just need to call all of these resources on your Terraform script. Or we've also developed a ready framework, which is called OCI landing zones that lets you set up standardized cloud environments using infra code from day one. So what is a landing zone? So simply, a landing zone is a collection of Terraform modules arranged in a reusable pattern. So instead of starting with a blank Terraform configuration. So you can grab and use these landing zones for you to start with a pre-structured layout that already understands how the Exadata components relate to each other. So it provides you with repeatable deployment framework, and it deploys the same Exadata resources as you would through the console or through custom Terraform. So we will just it just expresses those deployments in a standardized parameter driven form that your team can share and reuse. And we have developed this OCI landing zone for Exadata database service. So if you go to GitHub, um, go to github.com/OCI landing zones. And then if you search on the repository, so just type in Exadata, and then you'll see there Terraform OCI modules for Exadata. So that's the OCI landing zone that we have developed for Exadata database service on dedicated infrastructure. Okay, so this is again the repository. It contains these ready modules that you can use to easily deploy and manage your Exadata database service on dedicated infrastructure and OCI. And that you'll see there. Different examples based on different use cases that we have developed, and which will be the main focus of this tech talk. So if you go to this URL, so you'll see there a sample examples folder, and there you'll see some of the deployment patterns that are supported out of the box. So you can start with a doing a uh, quick start deployment, and you can also check other examples. We will go through each with this session. So you can so the idea here is that these are starting patterns. So you can use them as is, tailor that based on your requirements because the modules are composable. So if your organization has specific networking layouts, security rules required, then you can just easily tailor the ready uh, codes. And again, this is a ready framework that you can build with. Okay, so let's start with the quick start. So for this example, this landing zone quick start for Exadata database service on dedicated infrastructure. So this will create a an end-to-end deployment, starting from creating an Exadata cloud infrastructure uh, based on an availability domain that you provide, and also we'll create a VM cluster that you can provide where it will reside in terms of the network configuration, like which VCN and subnet. And inside the VM cluster, it will create a DB home based on a specific version and a container database inside that the DB home and in a pluggable database inside that container database. So, yep, I'll hand it over to Sheena just to walk us through this example.
Thanks, Leo. Right. So this is our Terraform GitHub repo. This is the examples that we have if we want to have a quick start of Terraform Exadata. And what we do is, if you basically just clone this into your VS Code, you should be able to see something like these examples. This is your repository that gets cloned into VS Code. So you basically just go to your quick start. The code starts from main.tf, wherein we specify all of the infrastructure configuration, the VM cluster configuration, the DB home configuration, the databases configuration, and the pluggable databases configuration, right? And then all of these variables are defined here. And then we have this input.auto.tf vars file. So it's actually given to you as a template. You can just rename it to input.auto.tf vars. We just provide our tenancy details, and you just provide your compartment OSIDs, the network OSIDs for NSG and subnets, and we provide the configurations for the Exadata infrastructure, like display name, shape, compute count, storage count, everything that we need to create it. You provide the VM clusters configuration, the compartment ID, and which infrastructure we want it in, which DB servers we want to use, the subnet ID, and all of these things. Now again, this GI version here, this is specific. It takes in 4 digits. So this is how we specify the GI version. And yeah, that's pretty much it. Similarly, we specify our DB home configurations. We specify our database configurations here. And then we specify our pluggable database configurations. Once we specify all of this, you basically just go to the quick start directory, do a Terraform init. Oops. That initializes your Terraform, and then we can just simply do a Terraform plan to see what it is going to create. So it basically just gives you an output of what all it is going to create. So here it's telling us that it is going to create this infrastructure with these specific values. It is also going to create a VM cluster with these specific values. And it's also going to create a DB home. So it's going to create this container database and a DB home with this display name and a pluggable database with this PDB name, which is the same as the one that we provided in our configurations. So once the Terraform plan is successful, we can simply go ahead and say Terraform apply. And once you do that, you should be able to go to your console and just see the things that are already applied there. So yeah, so it usually takes about 1 or 2 hours for the entire infrastructure, VM cluster, DB home, container database, and pluggable database to provision. And yes, after that time, you should be able to go and check in your cloud.
Yeah. So, Sheena, from the GitHub, there's a file where they can just specify all those inputs that will be used by the Terraform, right?
Yes. So when you go to GitHub and when you go to Quick Start, this is the file, like the template file you're talking about, right?
Yes.
Right. So this is the template file, input auto tfvars.template. When you go to this file, you can see all of the tenancy connectivity variables, the
Mm.
compartment values, network dependencies, infrastructure configuration, VM cluster configuration. And this is the same as, so you basically, when you use this, you just rename it to input auto tfvars. You just remove the template and then you can specify the values in your VS Code or whichever editor you're using, and then just do a Terraform plan and apply.
Yep. And there's also descriptions for each of the parameters that we added in the input file, right?
Yes, so
Yeah.
we have comments on where to get these values from.
Yep. Yep. Yep.
Yep, so
Okay.
that's about
So
it.
let's now move to the second second example.
Mhm.
Okay, so you can still see my screen, right? Okay, so we've shown the quick start um, module for the landing zone. So now there's also another example that they can see in the GitHub. It's deploying Exadata database service on multiple environments. So for this use case, so if they're looking into creating multiple environments like for development, test, and UAT, so they can easily spin up uh, like two or three Exadata cloud infrastructure with the VM cluster on it, database home, CDB, and PDB. And I'll go through the third example so that Sheena you can show both as I hand it over to you. And then we also have an example of deploying multiple clusters in the same VCN but different subnets. So if you want to um, create like on multiple VM clusters on one Exadata cloud infrastructure since it's multiple VM cluster is supported. So you can also do that, and we have already landing zone examples for that one, which will create multiple VM clusters on the same VCN, but using different subnets. And then we also have an example of deploying multiple VM clusters on the same Exadata cloud infrastructure, but this time using different VCNs. So I'll hand it over again to Sheena just to walk us through those samples in GitHub. You're on mute. I think Sheena, you're on mute.
Okay. Yeah, so we can have multiple VM clusters. Now, you basically just go to the creating additional VM cluster with multiple DB home, CDB, and PDB. I already have this code in my VS Code here. So this is the creating additional VM cluster with multiple DB home, CDB, and PDB. So I basically just go to this folder. It does the same things. We specify all of the configurations. We have a template file which you can simply rename to just remove the template and go to input auto tf vars. And then similarly, we just specify our tenancy connectivity variables, the input variables, and so here what we can do is, since we're adding multiple infrastructures, we have one infrastructure, sorry, we're adding multiple VM clusters. Here we can specify multiple VM clusters in the same configuration file. Like here we have specified VM cluster 1. And then if you see, we have also specified another VM cluster here, a VM cluster 2. So if you check the template, you should be able to see in the cloud VM clusters configuration. we have one VM cluster, and then we have another VM cluster that we have specified in the same configuration. So this basically, when you just rename it to the input auto TF it will be able to create two VM clusters in the same infrastructure.
Mm.
And
So,
after that, similarly, we can specify multiple DB homes in
mm.
the same database homes configuration with the same VM cluster. So we can specify which DB home. Let's say here we want DB home 1 to be in the first VM cluster that I created, and I want DB home 2 to be in the second VM cluster that I created. So I can do that mapping over here. Similarly, when I create the databases for this, for the database configuration, I can specify that I want my CDB1, which is the container database 1, to be in my DB home 1. And after all of the other configurations, I can add one more container database and specify that I want this container database to be inside DB home 2. So that's how we map all of the infrastructure, multiple VM clusters, and container databases and DB homes.
So the key here, Sheena, is that when they want to create multiple VM cluster, they just need to map it to the OSID of that Exadata cloud infrastructure, right?
Yes. So when you specify the VM cluster, you also specify which infrastructure we want it to be in. This is the same infrastructure key that we created when we created the infrastructures.
For the quick start. And then inside the VM cluster, they can also create multiple DB homes based on their requirement, right? So they can just easily tailor this
Mm.
script.
Yes.
Okay,
And
cool.
then similarly, you basically just go to whichever thing you're trying to apply. So let's say we're trying to create multiple VM clusters. We just go to we can simply go to that folder, do the same steps, which is a Terraform init, and then a Terraform plan, which is going to show me all the things that it's creating. It's creating a DB home, it is creating the databases, it's creating the VM clusters, the infrastructures, and all of that. And then, just like we have multiple VM clusters, we can also have additional DB homes. We can also have, additional multiple VM clusters in the same VCN or in the different VCN.
Mm. So for the use case of creating multiple VM clusters on the same VCN,
Mhm.
so from the input, they just need to make sure that for that network that network config block there, they
Right,
they just need to that's where they will specify the subnet ID. I mean the client subnet ID that will be used by the VM cluster. And then
right. So if you go to the folder for same VCN and you go to the template file, you'll be able to see that we have the multiple subnets and multiple network security groups. Now these subnets, this is let's say exa subnet key 1. We'll specify the OSID of the subnet where we want this VM cluster to be. Now this subnet key is mapped to the subnet ID that I have specified in my VM cluster 1.
mhm,
And the backup subnet ID has been mapped to exa backup subnet key 1.
yeah, and then both of I mean yeah both of the subnet IDs is part of that one VCN, right?
Yes. And similarly, I have, let's say, like I have specified this NSG exa client key. So I have mapped this to my VM cluster 1. This is how I map the things here. Similarly for the backup key 1. And then the same goes for my second VM cluster. I have the other subnet ID and the subnet backup ID. Now all of both of these subnets are in the same VCN.
Mm, yeah. And then if they want to like create the VM clusters on different VCN, so we also have that example, right?
Right. So if we go to the folder for different VCNs and go to the template, you can basically just the same way as before, except the only difference is that the subnet key 1 and the subnet key 2, they'll be in different VCNs.
Mm, yeah.
They
So
will still be mapped to the VM cluster the same way as before.
so this is very useful. Like if you want to do some isolation with your different environments like dev, test, and UAT. So let's say they have created their own dedicated CIDR for that uh, development or test, or it could be like on a like totally different VCN. Then they can also use this landing zone to, uh, I mean, using that use case.
Right.
Yeah. And then if they want to create like multiple uh database homes, for example, they have created their VM cluster. Like well, what I want is just to create multiple DB homes, container database, and pluggable database.
Right. So if you already have your infrastructure and VM cluster in place, we have a quick one where you just go to the creating additional DB homes with multiple CDB, PDB.
Mhm.
If you go to the template and similarly specify your tenancy connectivity variables, you can directly specify multiple DB homes here. Now you specify your VM cluster. Whichever VM cluster, you specify the OSID of your existing VM cluster, and this DB home is simply going to be created in that VM cluster. Now, if you want, you can also specify multiple database configuration. Like here, we've specified CDB1, CDB2. You could also specify multiple DB homes. We have DB home 1. Similarly, here you could add a DB home 2, and that's about it.
Mhm. So they can have like a mix of different versions for database home, and they can even have their own custom database software image as a database home when they codify it through Terraform.
Right. So you can specify, if you create a custom software image, you can
Mm.
specify it over here.
Yeah, so there's a parameter ready to call out a custom database software image. Like if they require a specific RU or release unit for that database home.
Yeah.
And then they can easily codify it. Let's say if I want to create four container database with let's say two pluggable database on each CDB, so they can just uh,
Right. So just like here, we have CDB1, we have CDB2, just specify two more, we'll get four container databases. Now we can map these container databases to whichever DB home we want them in. These are basically the keys or the references to the DB homes that we defined above. Like here we have specified DB home 1, right? So we created this DB home 1 over here. If we had created DB home 2, 3, we can specify which container database we want in which DB home. Similarly, you can have multiple pluggable databases. When we create a container database, it's already created with one default pluggable database. If we want extra pluggable databases, we can specify them here in our pluggable databases configuration.
Mhm.
Um, you just specify your pluggable database key, specify which container database we want it to be in, which is the same container database that we created above, right? And then we just give it a name, a password, and all of these things. And yeah, that's pretty much it. You can also specify um, like encryption details and all of that stuff.
Mm. Yep, this is great.
Yep.
So yeah, and then and this examples, these are all for deploying Exadata database service on dedicated infrastructure in OCI, right?
Yes.
Yeah. And then if they also want to like deploy it on a multi-cloud environment,
Mm,
then we also have those examples ready. Right?
right.
Yeah. So yeah.
Yeah.
Yeah. So if they wanted to extend it to multi-cloud environments, so there's also multi-cloud landing zones available for them to use. So for this example, it's Oracle database at AWS. So without the landing zone, if you want they want to codify Oracle database at AWS, so they just need to use this Terraform provider from the AWS side, and
Right.
this resources from OCI side, and they just need to call both providers on their Terraform script, and then this is the output. So it will deploy the required AWS resources first, which is the ODB network, and then the cloud Exadata cloud infrastructure and a VM cluster. And then from the OCI side, that will be the database home, CDB, and PDB. So same with Oracle database at Google Cloud. So we structure we're using the same structure. So the resources for the Google, it will be the ODB network, cloud Exadata infrastructure, and then cloud VM cluster, and then the rest, DB Home, CDB, PDB, will be part of OCI, and this will be the output. So it's like a quick start for them to provision a Exadata database service on Oracle database at Google. So same thing with Azure. So we also have landing zones for deploying for Oracle database at Azure, which it will create the required resources from the Azure side, starting from the resource group, the virtual network, and then cloud infrastructure, uh, the dedicated subnet that will be used by the VM cluster, and then from the OCI side, I mean, yeah, and then the VM cluster still with the Azure side, and then for the OCI side, same thing, DB Home, CDB, and PDB. So, Sheena, for multi-cloud, where they can find all this sample codes?
Right. So for multi-cloud, if you simply go to GitHub, OCI landing zones, and you just search for the Azure one, you should be able to find the Terraform OCI multi-cloud Azure repository. And then if you go to the examples, you can replicate the one that fits your use case into your editor, whichever VS Code editor or whichever editor you're using, and simply do the same process for Terraform init, plan, and apply. So just like Azure, you can also find the multi-cloud repo for AWS and a multi-cloud repo for Google
Nice. So they just need to search the repository and
on
type.
OCI landing zones.
Okay,
Right.
okay, that's great. Yeah. So we have covered different examples, use cases, both for deploying it in in OCI and also with the multi-cloud. And yeah, I guess that will be it. So we're going to open now the session for any uh questions or clarifications regarding the OCI landing zones. And yeah, so as we wait for those questions, I just wanted to share. We're also have an external Slack workspace in which we are uploading all this references. So we're sharing here get started guides, how to demos and gifts. We're also sharing replays of this Tech Talk series. So replays and also upcoming Tech Talk series. So the Slack workspace, it's Exadata dash database dash service. So yeah, so we'd like to invite everyone to join us with a discussion about anything about database cloud services on Slack. So here's the join link, and so how to join. So just click that join link URL or scan this QR code, log in with your email associated with your Slack, and then check your email for code to set up your 2FA, and that's it. So welcome to our workspace. We'll also be sharing the links to the OCI landing zones for Exadata database service on our Slack channel, and also the replay for this session. And yeah, so with that, this brings our Tech Talk session to an end. So again, my name is Leo, and my co-host is.
Name is Sheena. Thanks for joining us today. If you have any questions, we're still around for another few minutes. So feel free to ask any questions that you may have.
Okay. Thanks, everyone. Thanks for joining.